Hi folks, this is Nat, and this is going to be your first of a couple videos focused on different ways of looking at equations and how we can solve them. For this video, we're going to really focus in on the rules of working with equations. No matter how you go about solving an equation, you kind of have to do certain particular things. We'll go over those and kind of talk about why they are rules you need to follow. So the first and probably most important thing that I want you to remember is that an equation is like a balance, and let me explain what I mean by that. Regardless of what an equation looks like, what's on the different sides of it, when we see that equals sign in the middle, the thing that equals sign is telling us is that the two halves, the two pieces of the equation have the same value. Another way of thinking about it is that they're in balance with one another. So I'm not sure if you've used a balance in, say, a science class, but it's basically a device where you put things on both sides and, it tells you if they weigh the same thing by basically sitting evenly. And we can imagine that an equation is like that. When we see the equal sign in the middle at the beginning, it tells us that the two halves of the equation, whatever they might be, are sitting equally and are even and in balance. To make this easier to imagine, let's do something that we know is in balance. If I say 2 plus 2 equals 4, hopefully we can all agree that that's true. And what we can see is that the two sides of the equation, like we said, are in balance. 2 and 2 do indeed have a value equal to 4. They match. And as we go about solving the equation, in this case there's not really anything to solve, but as we go about manipulating the equation with the goal of solving it, we have to constantly be aware of that balance that exists and maintain it. Let me show you what I mean. When working with an equation, we're going to frequently do things like add or take away numbers. So for example, let's say that for some reason I didn't want this 2 here anymore, and I need to get rid of it. So the way I get rid of things in math, and we'll talk more about this in a second, is by doing their opposites, the inverse operation. So the opposite of adding 2 is subtracting 2. So I might add to this side of the equation minus 2, and what that does is it eliminates the plus 2. And now all I have in this side of the equation is just the 2 over here. Now what you might notice is that this equation no longer is in balance. It's not a true statement anymore. If I have 2 over here, it is not equal to 4 over here. I've messed up the balance of the equation. And as it turns out, the only way to prevent that from happening is by always doing the same thing to both sides of an equation. If I've taken 2 away over here on this side, then I have to take 2 away over here on that side, and that will maintain my balance. So 2 does indeed have a value equal to 4 minus 2. Now my equation's back in balance. And it's important to maintain that balance because anytime you lose it, it's no longer a true statement. And it's really important that we are able to trust that what the equation tells us is true. If it tells us 2 equals 4, that doesn't work anymore. And whatever answer we get from the equation is not going to be a true one. Let's kind of look at that idea with an actual real-life equation. I have here x plus 7 equals 19. Well, I could probably do some quick mental math to figure out exactly what the value of that x is. It's important to actually know how to do your work on an equation, so we're going to practice with some easier equations first. I'd really like to know what the value of this x is. And as it turns out, I can make the equation tell me what the value of the x is simply by getting rid of everything around the x. In this case, the plus 7 is the thing next to the x that's preventing the x from telling me what it is. So again, when we deal with equations, we're always going to be thinking about opposites. We're going to be looking at this x and saying, what's the opposite of the thing happening to it? Well, the opposite of adding 7 is going to be to subtract 7. And if I plop down a minus 7 next to it, I can make it go away. Now, if you were paying attention a minute ago, you might be saying to yourself, well, that's fine, but now your equation is out of balance. These two things were equal, and you did something to one side that you didn't do to the other. I haven't done anything to my 19, so if I remove 7 from the x plus 7 side of the equation, now I've thrown the whole thing out of whack. The way I keep that from happening is by doing, again, the exact same thing to both sides. I'm going to need to throw a minus 7 in there with the 19 as well to keep my equation balanced once again. And what I'm going to end up with here is the idea that x by itself now, since I've removed everything around it, has the value of 19 minus 7, which hopefully we all know is 12. Going back to the full equation from a second ago, I can see that that's true. If x does have a value of 12, 12 plus 7 does indeed equal 19. So I know that my solution is correct. Here's another example of that. I've got 15 is equal to x divided by 7. The first thing I'm going to point out is that the x is on a different side this time. And one of the things we need to get used to when we are dealing with algebra concepts is that it really doesn't matter where it is. I could switch it back around so it was x divided by 7 is 15, but it doesn't really matter. I don't have to. And again, the thing that I really want in order to figure out what the value of that x is to remove the things around it. If there's nothing left on that side of the equation except for the x, it's going to have a value of whatever is over here, and it'll basically tell me what it is. So, in order to solve, we're going to practice this. You might be able to do it in your head, but this is an important thing to practice. We're going to be eliminating the things around the x. So, I need to eliminate divided by 7. In math, we always eliminate things by doing their opposites, and the opposite of division is multiplication. So the inverse of dividing by 7 is multiplying by 7. And I've been writing it above, but it's important to kind of recognize it doesn't really matter where it goes. I could put it over here. And those two things are going to eliminate one another. Kind of makes sense, right? If x was, 14 and I divided it by 7 and then multiplied it by 7 again, I'd be back to 14. So I basically am making these things useless so that I can then say that they're gone. So I've eliminated my 7, or my divided by 7, and all I have left is the x by itself. Now the thing, again, that you want to notice is that I changed one side of the equation, and if I don't want the whole thing to fall out of balance and be an untrue statement, I have to do the same thing on both sides, which means multiplying by 7 over by the 15 as well. So all told, what I'll end up with, having eliminated my 7s and changed the other side accordingly, is that the final answer is x is going to have a value of 105. 15 times 7, 105. And again, I can go back and check to make sure that I'm happy with that by going back to my original and saying, well, is that a true statement like it ought to be? Is 105 divided by 7 15? If the answer is yes, which it is, then you're in good shape. If the answer is no, then you probably didn't do the same thing to both sides of your equation at some point. So let's take a second to summarize what we've seen. Here are some rules to remember. Whenever you do something to an equation, you have to do it to both sides. Again, it's like that balance idea. I'm going to throw the equation out of whack. It's not going to be a true statement anymore if I don't do the same thing to both sides. And ultimately what that ends up doing is giving me an answer or a value for the variable that isn't actually a solution. It doesn't make a true statement. The other thing I want to get at, and we're going to get more kind of experience with this in a second, is that we solve equations by eliminating the stuff around the variable. We always begin by looking at the variable, finding the stuff that's happening to it, and eliminating that stuff. And we eliminate that stuff by doing the inverse operations. So if I see an equation where I am adding to the variable, I'm going to subtract that, whatever is being added. If I see an equation where I'm dividing the variable, I'm going to multiply, and that'll get rid of the things that are happening to any variable. So we're going to take a couple minutes to just work through a few more examples and kind of talk about the logic. And I'm also going to show you kind of how we traditionally note what we're doing to equations in algebra, which is an important skill to have. You have to do things in a way that people can tell what you're doing. It's part of showing your work and communicating well. So here I've got 2 times f, which I would more frequently see written this way, 2f, and that equals 132. So the very first question is, where's the variable and what's happening to it? So here's my variable, f, and it looks like the thing that's happening to it is that I'm multiplying it by 2. The second thing I should ask myself is, what is the opposite of multiplying by 2? I want to get rid of that so that f is by itself, all alone, and the opposite of multiplying by 2 is dividing by 2. So I can either write that this way, divided by 2, or I can write it by just showing a line under the 2, like a fraction, divided by 2 that way. Since I divided by 2 on one side, I want to keep that equation in balance, so I'm going to have to divide by 2 on the other side. We traditionally note that those 2's next to the f are gone by crossing them out and then rewriting the equation. F must equal 132 divided by 2. And at that point, I have to figure out what that is. And it's 66. An important thing to do is always to come back to that original equation and see if the solution that you found is actually a real solution, if it makes it true. So 2 times 66 for f should equal 132. It does, so I'm good. F equals 66 is definitely my solution. Here's one where 2 things are happening to my variable. I've got m, my variable, and it looks like I'm subtracting 9 and adding 3, which is fine. If 2 things are happening to it, I'll have to undo both of those. So I'm going to begin by looking at the minus 9 maybe, and the opposite of subtracting 9 is adding 9. And again, I have to do that on both sides. That'll eliminate the 9's from my variable side of the equation. I'll get 14 for 5 plus 9, and that'll be equal to m plus 3 now. Again, the 9's have been eliminated. Now I've got the plus 3. I'll eliminate the plus 3 by subtracting 3, again from both sides of the equation. 3's are eliminated. 14 minus 3 is 11, and my answer is 11 is m, or m equals 11. Once again, got to go back and check. Did I find a solution correctly or not? There's a nice thing about equations is that they're basically self-checking. Just have to see if it makes a true statement. So m is 11, so 11 minus 9 plus 3. Well, 11 minus 9 is 2, plus 3 is 5. That does indeed equal the 5 I thought it would. I am correct. Here I've got 15 is equal to w divided by 6. So I'm, again, going to start with the variable wherever I find it. Here's w, and it looks like I'm dividing it by 6. The opposite of dividing by 6 is multiplying by 6. So I'm going to multiply both sides of the equation by 6, eliminate my division, and end up with w must then equal whatever 15 times 6 is. And I believe that's 90. But again, I'm going to check it. So 15 should be equal to 90 divided by 6. And 90 divided by 6 is indeed 15, so I am correct. The last thing I'll point out to you before I give you some practice problems is notice the way on all of these that I'm showing my work. I'm always showing how I undid what I did to the variable, and I'm always showing it on both sides. That's a habit that you need to develop as a student getting into algebra concepts. And the faster you start doing that stuff and noting your work clearly, the better off you're going to be when we get into more complicated equations. And here are your practice problems. I'm going to stress this, show your work. I may not give you credit if you do not show what you're doing to both sides of the equation, because that's your thinking.